Okay, so today we are going to start looking at or reviewing triangle and angle properties so that we are able to solve triangles and using not only trig ratios, which will be chapter 8, but in chapter 7, looking at relationships within triangles and deciding how they are going to be similar, which means that the triangle has particular properties that we can use to find side lengths or maybe angles or and apply those to real life situations, such as if you have a triangle that's easily measured and you know that it's a similar triangle to something that is more difficult to measure, then you can use properties of those similar triangles to solve for side lengths. And, maybe you want to find the height of a tree or how long a bridge should be over a river. And those are the kind of things that we're going to work towards. So in order to eventually decide whether a triangle is similar, then we need to review some things about the angles either inside the triangle or formed by the parallel lines of two triangles. Okay, so we are going to review, we're going to match the terms. So there's alternate angles, interior angles, isosceles triangle, complementary angles, opposite angles, supplementary angles, co-interior angles, corresponding angles, and the hypotenuse. And some of these words like alternate and supplementary and complementary angles, it's more important about the relationship that those angles have as opposed to remembering what they're called. Whereas something like the hypotenuse, we're going to review today, and we're going to need it for chapter 8 as well. Okay, so the first one we have here, we have two intersecting lines, and you can see the way that the angles are labeled, and some of them say A and some of them say B. And the reason they are marked in the same way is because these are opposite angles. So A is the same as angle A because they are opposite of the two intersecting lines, and B is the same as angle B because it's the inside opposite. Okay? The one to the right of that is that the angles opposite the equal sides. So this, if you have two equal sides, so that is shown with these two dashed lines here, that is saying that those two side lengths are equal. That means the two angles at the bottom there, you can see them noted with black dots. They are going to be the angles inside the isosceles triangle. And you can sort of tell that the angle at the top, at the apex of that triangle, is obviously not the same size as the two dots at the bottom. Okay, so this is going to be an important one for when we do 7.1. And so the last blank in that row, it talks about a right angle triangle. And how did I know it was a right angle triangle? Because we have this square here. Technically that's angle A, but it is a right angle. So then the hypotenuse, the longest side in the triangle, or sometimes we talk about it being the side opposite to the right angle, is called the hypotenuse. And we're going to use the hypotenuse today. We're going to review the Pythagorean theorem. And eventually when we get to the trig ratios, we're going to talk all about the hypotenuse and its relationship to the other two sides. And this year we would like to be able to solve for the angle. So how can we find what angle B and angle C are if we know some of the side lengths? That's what we're going to work towards. Okay. So then when you have the angles shown here, so we have drawn a we have drawn a straight line, and then the pink line has cut that line, not perfectly in half, but it has created two angles. So when you have a line cutting a straight line like that, then C plus D are going to be equal to 180. So when you have a straight line, sometimes we draw something like this. This is an 180-degree angle. So then the two angles formed inside are called supplementary. And they would add up to 180. So as much, like I said, as much as you don't need to necessarily remember that they're called supplementary angles, we might need this relationship that C plus D equals 180. So the two supplementary angles will add to 180. And then in the next blank, those are called complementary because now we are looking at, again, that right angle triangle. So now these two angles inside here, that perfectly perpendicular set of blue lines is going to make a 90-degree angle when you add the two angles together. Okay, and then one that we're going to use all the time is this relationship here. The sum of the interior angles in a triangle is 180 degrees. So then often, and you probably did questions like this in grade 9, often you're given two of the three and you are going to solve for the other one by subtracting the values from 180. And we're going to do that today when we do some examples in a second. Okay, so the next set of angle relationships have to do with transversal. So a transversal is a fancy word for a line that crosses parallel lines. So we often use, those are full pink arrows there. Sometimes the arrows aren't quite so full, they're just simply like this, and we're showing that these two lines are parallel, not equal necessarily in length, we don't really know, they're continuous, not like the isosceles triangle where we labeled those with dashes. We say that these are parallel. So then the blue line is cutting the parallel lines. Is it perfectly in half? No, but we're not too worried about that. We are worried about what is the relationship in the angles that cutting those two parallel lines has created. So when you have, this is sometimes called the Z pattern because it creates this Z. And what happens is the angle here and the angle here are what we call opposite. They're on opposite sides of the transversal. So we say that those are alternate angles. Oh, I'm not crossing them out, am I? We did alternate, we did hypotenuse, interior, supplementary, complementary, isosceles. Okay, so that's sometimes called the Z pattern. The next one is sometimes called the F pattern because it creates an F. And what you can see here is these two angles are now in matching or corresponding, sometimes, corners of the transversal. So we call these corresponding angles. Okay, so the word corresponding in life outside of angles and math class sometimes means, you know, corresponding colors, corresponding person could be somebody who matches with you. And so then these are called corresponding angles because they're in matching corners. Okay, so if you last year got to just talk about Z pattern and F pattern, that will be okay here. The next one is, of course, last but not least, we have co-interior. And again, sometimes this is referred to as the C pattern, but this time, they're not equal, they're supplementary, which means that they add to 180. Okay, So these are the relationships that we potentially could need as we start to solve triangles. But for today, we're just going to use these relationships as you probably did in grade 9. Okay, so this first one, we have 35 degrees in the bottom left corner of the triangle. We have 23 degrees in the bottom right, and then it's asking us to solve for angle D in the top corner. So you can simply, this is going to be the interior angles. I'll add to 180. So 180 minus 35 minus 23 is going to give us 100. Is going to give us 125 degrees. I'm sorry, 122 degrees. I'm just going to quickly fill this in case we need it. I don't know what just happened there. I leaned on my iPad too much and it deleted my work. Okay, same thing with the next one. These are both using the interior angle property. Now the triangle has quite a big angle at the top, 114 degrees. So 180 minus 114 minus 33 is 33 degrees. And if you did 180 minus 33 minus 114, you should get the same answer. Okay, so now with this question, you can use actually the interior property, but also when you have a right angle triangle, then because 180 is, or 90 is half of 180, you can actually do not just 90. So you can do 180 minus 90, because this is 90 degrees here, minus 58, or you can do 90 minus 58 and you would get the same answer, which is 32 degrees. But this is only true for a right angle triangle. So if that is not something that you would like to do, you want to do the same procedure every time, then use the interior angle property and do 180 minus 90 minus 58. Okay, number 4, which angles have the same measure as angle A? So when you do this kind of question, then you can do, you could look at the F pattern, you could look at the opposite first. It actually does not matter. Okay, so when you do, we're looking for the ones that are the same as A. So it has told us angle A. Okay, so right away, angle A is right in here. So most people would say, okay, angle A and angle C are equal because of that, because they are opposite. Don't think it's not easy to draw maybe we could do a Z, but we're gonna do something else in a second. I want to show you that's kind of cool too. So let's do an F. That one is way more obvious. Okay, so if we draw in the F, then we are looking for the angles that are in matching corners. So angle A and angle E are in matching corners, or they're part of the F pattern, or if you want to write corresponding angles, that's fine too. So you can definitely take a look and you know, there's kind of an oddly shaped Z, but if that's hard to see, you can do something else too. Because if angle A and angle C are opposite angles, that's easier to see. The F pattern in this shape of transversal is easy to see. But then, so if we have said that angle A and C are opposite angles, angle E also has an opposite angle, right? So angle E is equal to angle G. So if angle E is equal to angle A as well, then angle G is also equal to angle A. Okay? But there is, you know, you can sort of weirdly draw the Z in, but it's kind of hard to see. But that would work too. Then you would get a Z pattern, and A and G would be alternate sides of the transversal. Okay, so these questions are more like what you would have done in your grade 9 class. What we're going to try to do is then apply them to triangles. Okay, so you can see here that there are two pairs of triangles, and we'll look at tomorrow why or how to decide if something is a similar triangle or not. And some of the conditions that are going to be required for similarity is whether they have similar angles or not. So right away, most students will recognize that 102 is the opposite in the two triangles. They are, you know, apex to apex. So then that's going to be the opposite angle relationship that you can use. Okay, and now you have some options. So now we can do that you could use the properties of 180, the interior angles. So 180 minus 102 minus 48 definitely gives you an answer. Same with 180 minus 102 minus 30 in the top triangle gives you an answer. But it's kind of fun, or I'm gonna try to use the two. This time the Z I think is a little bit more obvious to see. Okay, so if you do this Z here, then that means that 48 is going to be up here as well. So the alternate angles are the ones that are opposite the transversal. And then you can do another Z this way. And now 30, the two 30s are the same as well. But if you would like to do, I'll write it up here. In the top triangle, you could have done 180 minus 30, minus 102, which is 48. And then in the bottom, once you did the opposite, I forgot to write Z pattern, sorry. Once you did the opposite angle and got 102, then in the bottom triangle, you could have done the same thing. But then you could also do this and use the Z pattern, for example, or the interior angle property and check your answer. You could even do that as well. Okay. So in number 6, the triangle in either case has two of the angles, and we don't really know anything else about their lines. They're not really touching. There's no opposites. So I think we have to use the interior angle property. Okay, so I'll do the one on the left first. 180 minus 50 is 80. Okay, and then what we're going to do eventually is, if you take a look at the other triangle, yes, we can do the same thing, but we're also going to talk about if the triangle is similar. So right now, two of the angles we have just shown are similar. That means the other, or the same, the other angle should be the same as well, which it is, but we can also do 180 minus 80 minus 50, which gives us 50 degrees. Okay, so these triangles have properties that are the same. When you look at number 7, this is tricky because there's actually 2 triangles happening here. And there's a trapezoid sort of shape as well, which can be kind of confusing. We are going to focus on, for Unit 7 and Unit 8, the triangle shape. Okay, so I'm going to highlight. So triangle A, actually, sorry, I'm going to use a highlighter. This big triangle, I'm going to ignore line DE for a second. So in this big triangle, I'm going to call that triangle A, B, C. Okay, we usually go in alphabetical order. Then the reason I chose that triangle is because in the big triangle, if we ignore the line DE, then we have 87 is the bottom left, angle B, and then 43 is on the bottom right, or angle C. So then you can use the interior angle property and find what angle A is. Okay, so let's do that. If you did this in grade 9, where you added the 2 angles together first, and then you had to do 180 minus the 2 added together, you get the same answer. So either way is fine. So now we have the other triangle. So now we have this little triangle at the top. So we have technically solved angle A, angle B, and angle C in that triangle ABC. So now I'm going to try to draw another triangle. Don't write this down, but it is tempting to do this. Some people's eyes will be like, oh, this is another shape. Yes, it is, but it is not the shape we are looking for. We want to focus on triangles. We are going to use that line DE though now, because this DE, AD, and AE make a little triangle. And I'm going to call that triangle maybe your brain saw that little triangle first, and that's okay, but then you would have had to use F pattern to solve for the angle D and angle E, which is fine, but that definitely, you would have to remember what that looks like. Okay, so it's up to you. So now in my little triangle ADE, it doesn't matter what side you start with, there's an F here. So angle B, which is 87 degrees, is going to be the same as angle D. But my Apple Pen, I'm not good with it, so I can't write that small, sorry. 87 goes in there for angle D. And then the other F pattern on the other side. So now angle C, which is 43 degrees, is equal to angle E. So in there is going to be 43 degrees. Okay, so all of the angles inside that triangle have been solved. And you definitely could have done the F pattern first and then done 180 minus 87 minus 43 to get the 50. You definitely could have done that. And it seems strange, how can the angles be the same? But the side lengths are so different. And that's why when we do the solving a similar triangle, we can use angle properties like F pattern, Z pattern, adding them up to get 180. But then when we do the side lengths, we're going to do something a little bit different. So in order to solve the side lengths, we are going to have to use something called a ratio. So here we're going to remind ourselves how to solve for x. Okay, so these are all different kinds of ratios. One of them, the x is in the top left. I would call this question the easiest type, and the one on the right hand side is the most difficult or requires the most brain power. And then the one in the middle isn't so bad. So they're written in this order on purpose, okay? We're going to do the easiest one first, and then the other two, we'll use our brains a bit. Now, not only is the first one easier because the x is in the top left-hand corner, but when you divide 2 over 5, or 2 divided by 5, it gives you 0.4, and that is not a repeating decimal. So not only is it easier because of where the x placement is, it's also easier because the decimals are not repeating. So my brain likes to check for that first. So I want to simplify a ratio like this as much as I can. I don't know what x is, so I can't do anything with that. But on the right hand side, 2 divided by 5 is 0.4. And now I don't have an ugly fraction, I don't have a repeating decimal, and so I can keep going and use inverse operations to isolate x. So on the left-hand side, if I am dividing by 15, then that means in order to cancel the 15 out, or the opposite operation of divide 15 would be multiply 15. Or you can think of it like, if I do 15 over 15, or 15 divided by 15, what's the answer? 1. So I have essentially changed or isolated the x value so that it's all by itself, 1x. Okay? Once you multiply by 15 on one side, of course we have to do that on the other side, and your answer is going to be 0.4 times 15, which is 6. Okay, so if I use the same strategy over here and try to do 7 divided by 12, you get 0.58333. And there it is. There's that ugly repeating decimal. And yes, you can round. To be honest, we're going to do these questions lots of times, and sometimes we have to round, and sometimes the question will say round to 2 decimal places or whatever sort of indicator like that. But there is a way that we do not have to use or stress about all of those decimal places as well. Okay, so I'm going to do these two remaining questions, 2 different ways, but it doesn't matter what you choose. You can also round. That's up to you. And there's also actually probably, especially if you use a Casio calculator, it says there is an ANS button, which means answer. So what you can do is 7 divided by 2, get this ugly decimal, but then not clear it out, and then you can multiply by 24, and you should also get the same answer as me. Okay, so when you have a calculator, and that's one of the reasons math teachers like the Casio calculator, is because sometimes it leaves it in exact form, which is fraction form, and that has advantages too. Okay, so there's plenty of ways that we can deal with this question. So I'm going to solve this middle one, and what I want to do, sometimes when we say, okay, we have to clear the fractions, right? We've done that before, and what that means is we need to essentially, some people will say get rid of the bottom. We would like to try to clear the fractions so that we have only multiplying and not dividing. Okay, so when you have a question like this and it doesn't give you a nice decimal, then, or even a whole number, then one of the strategies you can do is to clear the denominators. So on the left-hand side, we have a 12, which means we're going to multiply both sides by 12. Okay, and then on the right-hand side, we have 24, which means we're going to multiply both sides by 24. So then 12 over 12 on the left cancels out. 24 over 24 on the right cancels out. And now we're going to do 7 times 24 on the left-hand side. I'm going to write that down. If you would like to already do the math, that's up to you. And then on the right-hand side, we have x and 12. Okay, fractions have been cleared, and now we can go about solving for x. We do have to do 24 times 7, which is 168. And then we still have not isolated x. We then have to divide by 12. $168 divided by 12 is 14. Okay, so even though when I first tried my strategy of 7 divided by 12, I did not get a nice number. Eventually, the x value did turn out to be a nice number. So using that answer button and not clearing your work out, but continuing with it, pushing equals, and then using that as the number you divide or multiply by is not a bad strategy either. Okay? So we cleared the fractions by multiplying the denominators as you would have done before. But that can be messy, right? We had to multiply both sides by 12 and by 24. So if you're concerned that you're going to miss a number, you're going to forget to write them both down. The last strategy that we will do right now is you can do something called cross multiply. So when you cross multiply, you're going to cross. So we're going to do 10 and x and 8 and 15. And it doesn't matter which one you write down first. Most people, when they're first learning how to do this, they want the x value to be on the left-hand side. So that's what I'm going to multiply first. So if I do the cross multiplication, it's 10 times x. So I'm going to write that down. And then on the other side, the multiplication is 15 times 8. When you multiply, I'm going to write down some notes. X times 10 is the same as 10 times x. You could have done that. Okay, that's okay. And you could have done this. It's okay to have the numbers on, the left and the letter on the right, the variable, okay? I know that we try to keep the unknown variable when we're first learning how to solve equations, algebraic expressions. We try to keep it on the left-hand side, but that's not a requirement, okay? So let's continue to solve this. So now this actually looks more like what we just did on the other side. Okay, so on the other side, in the middle example. In the middle example, we cleared out the fractions by multiplying, which essentially gave us a second line here, this one, that looks like cross multiply. Okay? So again, both answers will give you the same thing. Whatever works for you will suffice. Okay, so 15 times 8 is 120. And then I'll leave the x. Oh, and now I can feel it. 120 and 10, those 10 is going to work out nicely. Isn't that fantastic? Okay. Divide by 10, and you get an answer of 12. When you have an equivalency like these, then the whole point is that you're creating a ratio where both sides, both tops, both bottoms of the fractions are equivalent. And a way you can, if you have time, you could you check? Could you check your answer? And the answer is, yes, for sure you could. You can sub in x and use left side, right side, just like we did all the way back in unit 1. Okay, so if I subbed in 6, for example, in the top of the fraction, 6 divided by 15 is 2 over 5. And again, if you use the Casio calculator, it reduces 6 over 15 to 2 over 5. You get exact form, which is a fantastic way to just quickly check, okay, I don't have to necessarily write out the whole left side, right side. I can just quickly check in my calculator and feel good about what I've done. Okay, same thing with the middle one. 14 over 24. Type it in your calculator, becomes 7 over 12 if your calculator leaves it in exact form, or you could definitely do the division, 7 divided by 12, and see if 14 divided by 24 gives you the same answer, and it should. Okay, so that's a really quick way that you could check your answer. All right, and the last type of question I'd like you to work on today is using Pythagorean theorem. And the big thing with Pythagorean theorem, of course, is making sure, so let's write down what the Pythagorean theorem is first. C squared equals A squared plus B squared. And when you have the A squared and the B squared, those two sides, it doesn't matter necessarily which one you write first. However, the C squared has, or side C in this case, has to be the hypotenuse. So we reminded ourselves what the hypotenuse looked like, the side, the longest side, which in this question is hard to tell because we don't know how long BC is, but we can say the side across from the right angle is the hypotenuse. Okay, so it's going to be 5 squared equals, and it doesn't matter. One of the things that we're going to do is label triangles later on, and we are going to usually label, you can see that the angles or the points of the triangle are labeled with capital letters. So then often we use lowercase letters for sides, and we often go across, or what the convention is to go across from the angle, that would be that side. So across from angle B is side B. Across from angle C is side C, and that works out wonderfully here. And across from angle A would be side A. So if you would like to label your triangle like that, then we are technically, according to our labeling, we are looking for side A. So that I'm going to call side B, or I'm going to substitute in that side B is 3. Yes, in the back of my mind, I'm thinking, okay, when I get the unknown side, I'm going to write down centimeters, but I don't really want to clutter my work, so I'm not going to worry about the units in my in using the Pythagorean theorem. However, because it is labeled here, don't forget to put centimeters in your answer. Okay, so 5 squared is 25. 3 squared is 9. Now I have to isolate A. So this time the variable's on the right hand side. That's okay, we can do it. So that means that we need to subtract 9 from the right hand side to get rid of the 9, which means I have to do that on the left hand side as well. 25 minus 9 is 16. And then don't forget, in order to do the inverse operation of squared, it's going to be 4. The square root of 16 is 4, and then don't forget to put the unit. When you do this kind of question, this is a nice perfect square root 16. If it wasn't, then you would have to round your answer. That's totally okay. So sometimes we'll stick to 1 or 2 decimal places, it would say in the question. And then the same thing with angles. When we get into using the trig ratios, it might be, it might tell you to round to 1 decimal place for the angles or to the whole number. Okay, so we are going to take the skills that we learned in grade 9, and we're going to take the next step and make sure that we can solve right angle triangles, but also non-right angle triangles, all different kinds. Okay, so work on the worksheet and hand it in so I can give you feedback. Thank you.